Hello and welcome. We are so glad to have so many people participating today. And we have a great presentation for you. This is a report that was created by Farnsworth Group, and Emily Jenkins and Grace Kurcab are going to be presenting it. This meeting is being recorded, and it will also be shared online for the future if you want to come back and look at it. And we're also going to be posting the slides. They will be available on the Facilities and Services website. And we will send a message to all of the registered attendees so that you can visit that when you are ready in the future. I do want to thank Emily and Grace for presenting today, and also thank Betsy Richardson, who has been the key client. And also my favorite is to thank the Student Sustainability Committee for their support of this effort. This is something that's for the University of Illinois Urbana-Champaign campus, the main campus only, and it is aligned with our Illinois Climate Action Plan. There's a goal there to have a more sustainable landscape. Previously, we did a campus landscape master plan and a resilient landscape strategy, and both of those recommended this effort, which is an evaluation really of our rainwater management. You'll see we're trying not to say stormwater. We love rain. We want to keep water here. It's rainwater. And this is a vision of what would be needed in order for us to actually meet our goals of a truly resilient rainwater program. So without further ado, I'm going to hand it over to Emily and Grace. Thank you all for being here, and thank you.
Great. Thank you, Morgan, for the introduction. I do want to mention that if you do have a question throughout the presentation, please write it in the Q&A chat box in the screen. At the end of the presentation, we will answer as many of those as possible. So I am Emily Jenkins. I'm an engineering manager at Farnsworth Group. I'm also an alum of the University of Illinois. I'm presenting today with my colleague, Grace Kurcab.
Yes, hello everyone. I'm Grace Kurcab. I'm a water resource engineer at Farnsworth Group in our Champaign office, and I'm also an alum of the University of Illinois, so I'm very excited to be here today to present.
We want to first begin by acknowledging Facilities and Services for the project, and to thank the Student Sustainability Committee for the funding for the project, and by recognizing that the land we are discussing today is the traditional territory of Native nations prior to their forced removal. Just a brief overview of what this forum will cover. We'll talk about the goal of the Rainwater Management Program, our approach to the program, and then the results and conclusion of what we discovered. So first of all, the goals of the Rainwater Management Plan. These include to redefine stormwater as rainwater. So the word stormwater, it really carries a negative connotation. It's often thought of something to capture, hide, or quickly dispose of. Instead, we are rebranding it as rainwater. This is a resource to bring life to the landscape in aesthetically pleasing ways. The next goal is to enforce the protection of waterways by utilizing green infrastructure. So green infrastructure are facilities that replicate natural systems by aiding in rainwater infiltration, evapotranspiration, flood reduction, improvement of air and water quality, and restoration of wildlife habitat. Rainwater runoff that is passed through these green infrastructure facilities will have fewer pollutants like fertilizers, pesticides, and sediment, and they'll also have less volume and less speed of water, therefore protecting the receiving downstream water bodies. The third goal of the program is to recommend green infrastructure facilities to address flooding and ponding issues on campus. So we've learned through modeling and open houses where flooding issues are on campus, and we have proposed solutions to alleviate these concerns. Next, the Rainwater Management Program addresses funding and marketing options for the recommended rainwater facilities, which we'll discuss. Finally, the program will deliver a plan to inspire educate, and nurture an ecologically diverse campus. So our approach consists of four main steps. First, to gather the data. Next, to understand existing conditions. Then to analyze proposed conditions. And finally, to compile everything together to create a plan that's usable and relevant. And now Grace will walk you through how we gathered information to begin the process.
Yes, so the first step was to review previous studies and plans, such as the Campus Master Plan and Campus Landscape Master Plan, and make sure our recommendations were consistent with those plans. For instance, we needed to be sure that we weren't proposing a new detention basin where one of those plans was proposing a new building. We reviewed a GIS layer provided by the university and identified where we had questions, and from that, where we needed to gather additional survey data to fill in those gaps. The university has several green infrastructure facilities already, so we worked with them to track down that as-built information so we could model those facilities accurately. And any remaining questions, we were able to pop over to campus, get eyes on the situation, and get the clarity we needed to keep moving forward. And finally, we really needed to understand how the system behaved in the real world. So we held an open forum with campus facility managers where they could share their feedback on what they were seeing on a routine basis. We decided on a virtual platform where we introduced our project, and then facility managers could either drop a comment online on this wiki map I have shown here, or they could stay in the meeting and voice their opinions and thoughts and issues of what they've been seeing. So these forums provided really valuable discussion, all of which we summarized in the following table and chart on the next page. So with this map here, this helped us verify what we were seeing in our existing condition model. And then in the proposed phase, we made sure to come back to this map and make sure that our proposed recommendations were addressing all of these issues.
After gathering all of the relevant data, we then began to put it together to understand how current conditions operate. So we started by delineating the campus into 9 drainage areas, shown here in the different colored shapes. Each drainage area flows to a single outlet point and is similar to the regions that were identified in the campus landscape master plan. Next, we identified major flow paths that are shown here in the dark black lines. Most of the drainage areas flow to the Boneyard Creek, either directly via overland flow or through storm sewer piping within Champaign, Urbana, or campus. The Boneyard Creek is in the northern part of the campus, shown here as a thin blue line on this map towards the upper part. 2 areas, areas 3 and 4, drain south through large pipes called the Kirby Avenue trunk line and the Vet Med trunk line to the headwaters or beginning of the Embera River. All the existing detention facilities were then identified and mapped, and they're shown here in the shapes of cool colors. The university currently has several large regional facilities to manage rainwater, but they're not retaining and infiltrating enough rainwater to meet the current standards to protect downstream waterways. And finally, we modeled the existing conditions within a modeling software called PC Swim. All of the lines and circles that are shown here represent storm sewer manholes and pipes. This model can tell us where flooding occurs, which manholes surcharge, which means which manholes have water coming out of the top, and what rate of water is leaving each area for a particular rain event. This model was used to identify locations of ponding and flooding. It was also used as the basis for adding proposed green infrastructure facilities to the campus to meet the university standards. A quick note about rainfall. The rainfall that we used in all of our analysis was the 100-year rain event, which is the rain event that has a 1% chance of happening every year. The most up-to-date published rainfall data were used for the analysis, which is 3.49 inches of rain falling within a 1-hour period.
Yeah, so next we'll get into how we analyze the proposed conditions. So first I'll explain the basis for our analysis criteria, and then we'll get into the method of how we recommended green infrastructure, as well as how those green infrastructure facilities were modeled. And then I'll walk you through the different green infrastructure facilities that we are recommending throughout campus. So the first step in analyzing our proposed conditions was to define our analysis criteria. Per university design criteria, our goal was to detain runoff from a 100-year storm, or a storm that has a chance of occurring once every 100 years, and then release that at a rate of 0.18 CFS per acre. So for instance, if your drainage area was 100 acres, our release rate goal would be 18 CFS. So our goal was to accomplish all of this by implementing green infrastructure. Now, this criteria is newer than a lot of the existing development throughout the university, so it was quite a difficult task. There's a bit of catching up to do, but ultimately, we were able to put together recommendations for each area that meet this criteria. So we used a wide range of green infrastructure to meet this criteria. Depending on the type of facility, we modeled it slightly differently in PC Swim, and I'll get into what each of these green infrastructure facilities are in the following slides, but I just want to give a quick overview. So some were modeled using low impact development controls, or LIDs, in PC Swim. More detention-based facilities were modeled using storage nodes, and then green roofs and native vegetation were modeled by modifying the subcatchment. So I'll walk you through the different green infrastructure facilities we're recommending. So on the left here, we have an infiltration basin, which is a storage area similar to a detention basin that can hold runoff, but it also includes a gravel storage layer and a layer of soil remediation to encourage infiltration back into the ground. We've recommended all of our infiltration basins throughout campus to be vegetated with native plants to just further assist in that infiltration and evapotranspiration. Permeable pavement can take the form of porous pavement, as shown at the State Farm Center, or permeable pavers, as I have shown here. So rainwater can pass through the pavement or between the cracks of the pavers into a gravel storage layer beneath, and can eventually infiltrate back into the soil, encouraging that groundwater recharge. So in the top left here, this is actually a picture of the Red Oak Rain Garden on campus. A rain garden is a shallow, low-lying area with a soil remediation layer, as well as plants that can treat and store rainwater as it falls, and they're often seen around downspouts. Below that, cisterns or rain barrels are above ground storage containers that collect rainwater from roofs, gutters, and downspouts, and the water can be used for irrigation purposes. And then on the right here, we have a vegetated swale, which is essentially a broad, shallow channel that's planted with native vegetation, in our case, or grasses, that can help convey water, but also give the rainwater a chance to infiltrate into the ground. So underground storage systems typically consist of large pipes or concrete boxes, as I have shown on the left, but they can be configured to meet the needs of the surrounding landscape. Underground storage systems are very beneficial because they can hold a large volume of water, but still release it at a very slow and controlled rate to the downstream sewers. In certain areas throughout campus, we're recommending retrofitting abandoned steam tunnels to be used as underground storage systems. So using this existing infrastructure is a great way to reduce construction costs of this facility long term. Detention basins are above ground storage areas that detain water until it can be slowly released to the downstream system. They can be either wet, as I have shown here, or dry, and can include walking paths and shelters to add recreational value and for people to enjoy. A wetland is similar to a detention basin, but includes a soil remediation layer that encourages that additional infiltration. It also holds a shallow depth of water for wetland plants to grow and to provide habitat for wildlife as well. On the right here, we have a tree box, which is another type of green storage system. It consists of a tree planted in engineered soil media contained in a box underground. So these are typically seen in parking lots, sidewalks, or adjacent to streets, and they're designed to collect that first flush or that initial runoff after a rain event and treat that and the pollutants prior to discharging into the subsoil or back into the sewer system. Green roofs are typically constructed on buildings with relatively flat roofs and roofs that can support that additional load of the soil. Green roofs can be planted with sedums and succulents, or they can even be transformed into an urban rooftop farm. They reduce the amount of impervious area, provide additional rainwater storage, and help cool the roof as well, reducing in the mechanical costs of the building. A simple and effective way of managing rainwater is to plant areas with native plants. This native vegetation helps to slow runoff down, allowing it to infiltrate back into the ground. It also encourages evapotranspiration, provides habitat for wildlife, and adds aesthetic value to the area. And this is consistent with the recommendations in the campus landscape master plan to um, increase the use of native plants throughout campus.
So what does all of this mean? Up to this point, we've collected a lot of information about specific problems on campus. We know how the current system behaves, and we've added a lot of rainwater facilities to our existing model to manage the rainwater runoff from each area, therefore decreasing the amount of runoff and flooding significantly. So the first result to share is that each of the 9 proposed areas, they do meet the university's standard of 0.18 CFS per acre for each of the 9 areas with the recommendations that we've provided. Grace and I will walk you through each area and show some highlights of rainwater facilities recommended for each area in the next set of slides. So first of all, this is area 1 called the South Quad District. It includes the South Quad area from Mount Hope Cemetery to the south to Nevada Street to the north. It includes PAR and FAR and everything to Lincoln Avenue on the east side and stretches to 4th and Gregory on the west side. This figure shows all of the proposed rainwater facilities throughout Area 1. Combined, they hold or infiltrate a total of 1.5 million cubic feet of water. Quite a bit of runoff comes from the cemetery due to the slope of the land there. We suggest capturing a lot of that runoff from the cemetery to underground detention systems and the complete Green Street along Kirby Avenue. The existing release rate of Area 1 is 187 CFS. With our recommendations, the proposed release rate is at 26 CFS, and that's for a 100-year event. These next couple of slides show a zoomed in version of different locations within Area 1. This first one is on the western side. The light green shapes are permeable pavement throughout most of the parking lots and along 6th Street that will manage the rainwater that falls directly on the large areas of pavement. The brown clouds are native vegetation areas adjacent to the South Quad and near Temple Hoyne-Buell Hall that will filter and slow runoff, as well as encourage infiltration. The light blue rectangle is a large underground detention facility underneath the South Quad that will provide storage for all areas upstream of the facility, but will not be noticeable to university users. In the eastern portion of Area 1, we are recommending a dense array of rainwater facilities. So Illini Grove is within this area and is helping to slow water down and infiltrate rainwater. Some proposed recommendations include green roofs on several buildings near Searcy and Bevere Hall, where Bevere Hall's green roof could be used for a produce garden for use in the cafe. Other recommendations include utilizing abandoned steam tunnels as rainwater storage north of Allen Hall, multiple permeable parking lots, and a decorative permeable paver promenade sidewalk north of parking lot F28. Cisterns can also be used as irrigation to capture roof runoff from the greenhouses. The Red Oak Rain Garden and Dorner Drive Retention Pond are shown on this map in the dotted outlines to denote that they are existing rainwater features. The Red Oak Rain Garden is an amazing example of the beauty and function green infrastructure facilities can provide. In the southern portion of Area 1, we recommend rain gardens within the medians of College Court, as well as small areas of permeable pavement in the courtyards of PAR dorms. One building of PAR could be converted to a green roof as shown in that dark green color. So Area 2 includes areas of university housing and Greek housing on the west side of campus. It includes the Eikenberry Commons, Armory, various athletic fields adjacent to Stadium Drive, and areas north of Memorial Stadium. This exhibit shows all of the proposed rainwater facilities recommended for Area 2. Combined, the green infrastructure facilities provide 933,000 cubic feet of storage and infiltration. The drainage area for this is 111 acres, and our proposed release rate with all of the proposed recommendations is 15 CFS. In the eastern section near the Armory, we are recommending a couple rain gardens near the west end and a small underground detention storage facility below the southern sidewalk. We also recommend converting lot E4 to a permeable surface. Just north of Memorial Stadium, we are recommending converting the large parking lots to permeable pavement and adding rain gardens to the edges of them to provide additional runoff treatment and storage. Permeable pavement is an easy way to remove large portions of potential runoff from the storm sewer system and instead keep the rain in place where it can recharge the groundwater. The Eikenberry Commons master plan had identified several green infrastructure facilities, and our rainwater program continues to build upon those ideas with a wetland in the center of the commons, native vegetation, and several rain gardens throughout the area, and sections of permeable pavement on Euclid Street and sidewalks. And in the western section of Area 2, the soccer fields are recommended to be converted to permeable turf and storage. This is an interesting product that provides a layer of rainwater storage beneath the turf, while the surface can be grass or artificial turf within a structured mesh layer. In addition, a large rain garden can be added to the area around the basketball courts to treat and infiltrate rainwater.
So Area 3, the athletic district, is bounded by Neal Street to the west and includes the industrial areas along the railroad from Goodwin to St. Mary's Road. It also includes the State Farm Center and the university baseball and softball fields. So with all of the green infrastructure we are recommending, these facilities achieve a total of 2.09 million cubic feet of total storage. And we're also able to reduce the release rate by 92% from 396 CFS to 33 CFS. So in the northern section, we're recommending several large green roofs, but I also want to highlight the Stadium Terrace playing field. Here, we're recommending several below ground improvements, including an underground storage system on the south side, as well as permeable grid pavers in the drive aisles of this field. So these pavers consist of a plastic grid system that's planted with soil and grass atop a gravel storage layer. So this allows for infiltration and storage while still supporting vehicle traffic above it. So this field can still be used for tailgating in the future. We're also recommending adding trees alongside the drive aisles to provide that additional cooling as well as evapotranspiration. So in the western section, we have the E14 parking lot. Here, we're recommending underground storage to detain a large volume of of runoff, coupled with permeable pavement in the drive aisles, as well as tree boxes throughout the parking lot. Similar to Lot E14 in the central section, we're recommending underground storage, permeable drive aisles, and tree boxes. The northeast lot already contains an existing section of permeable pavement, so we're really just expanding upon that idea throughout the entire State Farm lot. We'll couple these improvements with a Green Street transformation along Kirby Avenue, which includes adding rain gardens and tree trenches. In the eastern section, we propose continuing that Green Street transformation down Kirby Avenue. Between the baseball fields and the track and field, this is currently somewhat of an underutilized space, so we thought this would be a great location to incorporate artful rainwater to really maximize this area. So in the bottom left-hand corner, you'll see a rendering of what this area could look like. We suggest adding permeable pavers in a very stately pattern, lined with rain gardens and trees to intercept rainfall, provide habitat, and add additional cooling. These other images showcase other artful rainwater concepts throughout Area 3. In the upper left-hand corner, we're suggesting what we're calling a green wall, similar to a green roof, but containing vining plants that can add additional storage as well as beauty to this highly impervious area. Now, the Campus Landscape Master Plan mentioned a desire to make these crosswalks in this area more visible and more prominent. So here we're suggesting adding permeable pavers in the shape of a block I to show that Illini pride. So similar to all of these ideas, we've aimed to incorporate artful rainwater throughout the entire campus. These concepts really highlight and celebrate the importance of rainwater, while also making it a beautiful and sustainable space for students and staff to enjoy. Area 4, the Vet Med District, is bounded by Lincoln Avenue to the east and Windsor Road to the south. The Vet Med District includes a lot of open agricultural land, athletic fields, as well as the Vet Med campus. So you can see here that this area is not as densely packed with green infrastructure, but regardless, these recommended facilities store a total of 850,000 cubic feet of water and reduce the release rate all the way down to 0 CFS. So in the northern portion of this area, we recommend areas of permeable pavement, as well as that permeable turf and storage that Emily had mentioned in Area 2. But one area I want to note is the storage facility at the soccer practice field. This will function as a shallow underground cistern, so it can collect rainwater, and then that water can be used to irrigate the soccer fields as needed. So we're able to manage most of the runoff from this area by routing the trunk line down Lincoln Avenue to the wetland shown here in magenta. This wetland provides most of the detention we need for this area, as well as additional water quality benefits. However, if built in this recommended location, the proposed equestrian facility from the Campus Landscape Master Plan will need to be relocated. So these large agricultural areas lend themselves really nicely to using more native vegetation to slow the runoff down. We've also recommended a vegetated swale throughout the farmland to provide additional storage here as well. Area 5, the Law District, includes Mount Hope Cemetery, the Law Building, as well as the E15 parking garage. So Mount Hope Cemetery is not owned by the university, so improvements were not suggested there. But regardless, the facilities that we did recommend can store a total of 89,000 cubic feet of water and also reduce the release rate down to 0 CFS. So this area includes conversion of parking lots, sidewalks, bike paths, and as well as street parking lanes to permeable pavement. These areas of permeable pavement are very important to intercept runoff from the Mount Hope Cemetery since green infrastructure can't be added there itself. We recommend adding a green roof to the law building as well as an infiltration basin to the west, which can be optimized to serve as an outdoor study space for students.
So Area 6 is the main quad district. This area, as with Area 7, 8, and 9, were shown in the Campus Landscape Master Plan. The same green infrastructure facilities from the Campus Landscape Master Plan are shown here, just with storage calculations performed on them. The main quad district encompasses the center of campus, bounded by Armory Avenue on the south, Wright Street to the west, Green Street on the north, and South Matthews Avenue on the east. The open turf area is its centerpiece, with Follinger Auditorium at its south end and the Illini Union at its north end. Within the main quad area, the recommended improvements focus on courtyard enhancements with permeable pavement and aesthetics, turf restoration along its open space gathering places, soil restoration of the main quad open area, and an underground cistern to store rainwater. Tree wells are also proposed along the complete green streets along the perimeter of Area 6. The total storage of rainwater within Area 6 is 169,000 cubic feet. The proposed release rate meets the standard at 6.5 CFS. Area 7 is the engineering quad district located at the north end of campus. It is bounded by Green Street to the south, 6th Street and Wright Street on the west, and University Avenue on the north, and Matthews Avenue and Goodwin on the east. The North Quad and Bardeen Quad are both included in Area 7. The main focus of rainwater management for Area 7 is a stream restoration along the Boneyard Creek, which also includes a small wetland adjacent to the stream. An underground cistern within the North Quad is also recommended, as well as permeable pavement along sidewalks and parking lots. The total amount stored in this area is 8,000 cubic feet to achieve a release rate of 10.6 CFS, meeting the university standards. Area 8 is the Urban Town and Gown District. The Urban Town and Gown is straight west of the main quad, bounded by Armory Avenue on the south, 4th Street on the west, Green Street to the north, and Wright Street to the east. The rainwater facilities recommended in this area are centered on a streetscape revitalization. Streets will incorporate permeable pavement and parking lanes, shoulders, or across the full street. Bioretention cells will line streets and provide infiltration and habitat along the street corridors, and tree boxes will support trees for shading, cooling, and rainwater storage. The total storage for this area is 9,000 cubic feet, which will reduce the rate of water leaving this area from 6.9 to 6.9 from 21 CFS. And Area 9 is the Urban Campus District on the north side of campus. This area is bounded by Nevada Street on the south, Matthews Street on the west, University to the north, and Lincoln Avenue on the east. The Boneyard Creek runs through its north end, bisecting the area. Recommendations within Area 9 are characterized by a continuation of the stream and wetland enhancements along the Boneyard, daylighting portions of the Boneyard Creek, permeable pavement within streets, and rain gardens lining streets to capture overland flow from buildings and sidewalks. Also, in underground detention areas to store and slow rainwater runoff. Overall, it's a lot of results over a large campus area. So how did we compile everything to create a usable plan? So first of all, we made the plan very visual with several maps, exhibits, and figures showing several of the maps we've shown you. All of the technical information and methodology is located in the appendix, so it's available for those who wish to know more, but within the body of the report, we rely on maps, graphs, and tables to really tell the story. Next, in addition to the recommendations for green infrastructure, we also made recommendations for improvements to the university's standards associated with rainwater and runoff. For runoff calculations, we propose that the 0.18 CFS per acre standard be met for development and redevelopment within campus. We also recommend reducing the runoff rate for the 2-year storm in addition to the 100-year storm. So the 2-year storm event is the rainfall that has a 50% chance of occurring each year. As a more frequent rain event, this size of storm can cause significant damage to downstream waterways through erosion and flooding. So it's important to manage this small size storm as well as the large events. The methods acceptable to the university are outlined in detail in our revised standard recommendations so that all developers are using the same techniques in their calculations of runoff and storage volumes. The standards section on green infrastructure has several suggestions in it to provide guidance on design criteria and maintenance for all the green infrastructure types we mentioned today. Providing information to the developers will encourage more installations of green infrastructure and a consistency between designs so that the university staff can maintain all the facilities in an efficient, consistent manner. Finally, the erosion and sediment control standards has several recommendations within it to add more statements regarding temporary and permanent seeding to achieve 70% stabilization of the site before a contractor can be finished with a project. More stringent standards on the use and limits of erosion containment controls like silt fences, straw bales, and silt socks are also recommended. All recommendations have been given to facilities and services for review and eventual approval and implementation. We've shown you a lot of recommendations over the campus to manage rainwater and runoff. One big question in your mind might be, how does the university intend to pay for these projects? Well, with the updates to the standards requiring development and new development and redevelopment to meet the 0.18 CFS per acre, along with this plan that details what type of rainwater management facility should go where and how big it should be, developers can incorporate many of these projects into new or redevelopment projects on campus. Facilities and services can work with the developing client to ensure rainwater is being stored, infiltrated, or detained in some manner to reduce the overall release rates of the project site and ultimately the area of campus. So these projects will be built over many years as new projects are developed on campus. There is an opportunity for facilities and services to build some of these larger regional rainwater projects as standalone projects. For those situations, the plan provides several grant and loan options that the university can apply to for financial assistance. In conclusion, ultimately, the goal of this program is to challenge and change the mindsets of the university users to see rainwater facilities and green infrastructure as part of the fabric of the campus. Several small installations of green infrastructure facilities can effectively manage rainwater runoff while providing additional benefits like reducing the urban temperature, providing habitat for pollinators, small birds and mammals, and adding beauty and created spaces to the landscape. In order to change the mindsets of university users, we are first redefining the term stormwater as rainwater, an asset to be celebrated and retained on campus. Next, we have provided knowledge about the existing system and how the storm sewer behaves after several green infrastructure and other rainwater management facilities are installed. With smaller, more visible facilities to manage rainwater, individuals and small teams can feel empowered to understand how the facility improves the rainwater management near their building and celebrating the life-giving essence of rainwater. Through the rainwater management program, we also recommend green infrastructure facilities to both protect the water quality on campus and downstream of campus, as well as improve flooding and ponding issues within campus. The facilities recommended are varied to provide visual interest and proper runoff management. The plan has addressed funding and marketing options of the recommended projects. And finally, the plan was created to inspire, educate, and nurture an ecologically diverse campus here at the University of Illinois, Urbana-Champaign. With that, we really thank you for attending this public forum today. If you have a question, please write it in the Q&A tab of the screen and we'll get to as many questions as we can. If we don't answer yours or you have a follow-up question, please email me or Grace at the addresses shown on your screen. Thank you very much.
Yes, thanks everyone. Taking a look here at the Q&A, we have a couple questions posted already. The first one was, what are the additional water quality benefits of a wetland as compared to a permeable parking lot?
That's a great question. So a wetland, when water enters a wetland, the plants and the soil can really help filter the water coming through it. So there's all sorts of, say your runoff has a lot of nitrogen in it. A lot of wetland plants are nitrogen fixers, so they take out that nitrogen before releasing the water downstream. So even though both facilities of a permeable pavement parking lot and a wetland are storing the water and helping it infiltrate, there's that added cleaning that the wetland plants can do of taking out nutrients. There's also more evapotranspiration that happens in wetlands as the plants take up the water and release it to the air and use it in their transpiration. So overall, wetlands are a little bit more ecologically in tune and do help clean the water a little bit more efficiently.
Yeah, kind of a follow-up question to that. Were there specific water quality benefits noted in the plan, such as percent reduction in specific pollutants, total dissolved solids, or similar?
We did not get into the water quality benefits of these of each area. So we do note in the plan what facilities do have a water quality component. So kind of running through all the green infrastructure facilities, which ones do have water quality benefits and which ones are more storage focused, but we did not put any kind of numbers or calculations to how each area performs from a water quality standpoint. We were focused mostly on water quantity.
Great. Another question was, what options are there for retrofitting an existing impermeable pavement parking lot to include green infrastructure?
So most of the times when we're recommending these permeable pavement parking lots, some of them are new and in good shape throughout the university. So we're not recommending going and tearing out a perfectly good parking lot, but instead when a parking lot has reached the end of its life cycle and they're looking to repave it and redo it to put in a permeable parking lot instead. So this is a process where so the layers of a permeable parking lot include a layer of gravel below the pavement, and that's where you have a lot of voids in the space to really come in and let the water store and kind of be next to the soil to infiltrate. And then you'll have the pavement layer on top, and the pavement is either porous or it's that pavement with the pavers, I'm sorry, with the spaces between to let water down into that storage layer. So it is a more involved process to create a permeable pavement parking lot.
Mm-hmm. Okay. And there was another question related to the green streets that was recommended in the campus landscape master plan. And if we could just describe in a little bit more detail the type of design and what is being envisioned for that.
So a green street, a complete green street can mean a lot of different things, but mostly it's looking at a street and incorporating a lot of permeable pavement, either on the kind of parking aisles or through the drive aisles of a street, putting in rows of vegetation along the side of it, whether it be a little trench of rain garden alongside each side, or tree boxes lining the street. So you have those infiltration pockets. A lot of times it's putting in a median in the center of the road with more green infrastructure storage things, like either a rain garden in the middle or a bioswale to take the water and funnel it to where you need to go, but it also has that infiltration properties. So it's really putting in as many green infrastructure elements as possible within that street corridor.
Great. Okay, and this question is related more specifically to Area 2. They were wondering, should we include the Greek houses in our plan, mentioning that anything north of Gregory Drive between Armory Avenue and Oak Street are owned by the city of Champaign.
Right. So we have a little bit of that area, and so a lot of the recommendations we have in those areas are kind of on the streets. And if they're owned by the city of Champaign, it would be probably some conversations with the cities, and yeah, maybe we need to take another look at that to see where those boundaries are between the entities.
Mhm. The next question was, what were the limitations in adding more rain gardens and native plants throughout campus? Why utilize seemingly more permeable pavements and storage?
So some of the limitations with rain gardens is that they are smaller facilities. So once you get to a rain garden, the depth of a rain garden for storage is you don't really want to go much deeper than 2 feet of storage from the top to the visible bottom of a rain garden. And then underneath you'll have kind of a storage layer of amended soil that is specifically mixed to really infiltrate more and to store more water. And so all of those elements in a rain garden provide a limited amount of storage. So to be able to provide the amount of storage needed for these large areas that have a lot of impervious area runoff coming to it, we would need to take pretty much all of the turf area and convert it to rain gardens if that was our primary mode of management. So instead, we tried to take a lot of the impervious area out of the equation by putting in permeable pavement. So when you put in a permeable parking lot, then all of that water that's falling on that pavement is pretty much out of the system. So it's the parking lot is taking care of its own runoff, and we don't have to worry about that from a management standpoint of rainwater. And then we can focus the rain gardens on managing the runoff from buildings or sidewalks or just overland flow. So there are certain limitations for these green infrastructure facilities. And as you move forward from a new development standpoint, if you're putting in a new subdivision or something, it's very easy to incorporate all of these in the land kind of planning. But to retrofit things, as we're doing at the university when everything is built out, it takes a little bit more creativity. And the more water we can get off of out of the storm sewer pipes and kind of out of the management program, the better.
Yeah. So the next question is kind of dealing with more of the maintenance aspect. The question is, how do you prevent or deal with silt or dirt filling in permeable pavement and the rock storage space underneath?
Yeah, that's a great question. We didn't really talk about the maintenance of these facilities, but there is a layer of maintenance that is required to keep all of these facilities functioning at the level of which they're installed. So for a permeable pavement parking lot, um, what we typically suggest is getting a vacuum truck. And so this a vacuum truck will come along and just kind of suck up all of the dirt and sediment within that top layer of either porous pavement or along those pavers. And so it'll take up all of that sediment. Sometimes in paver situations, you've got to re-put down the little pea gravel that goes in between the spaces then. But if you do that on a regular basis, then you won't have any issues of sediment getting down into that storage layer in the bottom and clogging anything. So um, the amount that you do that, or the kind of regularity, it depends on the site and kind of what you're seeing get onto the site. If you have a place near an area where you get a lot of kind of sediment and debris, then you're going to want to clean it more often. But we usually say annually, once every year is a pretty good bet to keep it up to speed and maintained. Kind of along that same vein, other maintenance issues that you'll have to kind of keep up with. Rain gardens require weeding and pruning, just like any garden. They also will get sediment within them, so dredging that sediment once in a while, and you might need to replant, that kind of thing. But I recently saw some research about green infrastructure maintenance, that doing these little things every year or on a regular basis, it seems like a lot at the time, but it's really less money than if you have a large pond and you need to replace that large pond after a while, or kind of these bigger projects need to be kind of redone. And so that capital cost of redoing a larger facility is more in the long run than these little smaller maintenance items of green infrastructure.
Yeah. And just kind of a follow-up to that, does a leaf vacuum truck have the ability to be used for vacuuming permeable pavements?
I don't think so. I think it's a different type of truck, but yeah, I could follow up with you on specifics if you email me.
Then we have another question, kind of related to the money side of things. Is there any rough idea as to budget for this plan based on today's dollars?
Yes. So within the plan, we've given kind of a high dollar range of costs of all of these projects. And so in the back of the report, there's kind of a summary of all of the projects that are recommended with a kind of range of what the cost would be in today's dollars of those projects. We didn't total it up, but it is a large amount. It's a lot of water that we're talking about storing and infiltrating and managing. And so it's a sizable amount, which is why we don't intend for this to be done just like that. It'll take kind of piecemeal as development occurs throughout the campus to start integrating all of these rainwater management facilities throughout campus.
Great. The next question is specific to the Crop Sciences Research and Education Center. They would be interested in rainwater collection for potential irrigation, and they're wondering how this would fit into the plan.
Well, I think that's great. First of all, that's wonderful. And, I think that it can be done. So the things that we have recommended are, our starting point. So a starting conversation. It's identifying places where where facilities can be proposed. But something like this is a great conversation to be having with this. So, you know, there's a need, there's an interest, and that can be incorporated into the future of the rainwater management in that area for sure.
Definitely.
Grace and Emily, also just to add to that, Darren, we have a request, I would say advocacy letter into the state to allow for water reuse. Rainwater collection has to have a approval from the state in order to reuse it. So we have that conversation underway, and I'll make sure that we connect you with our team that sent that letter, and perhaps we can have a follow-up conversation with you and the College of ACES. Thanks.
Thanks. We have another question related back to maintenance. How will our extreme temperature changes affect the maintenance of the pavement and other structures?
Yeah, that's a good question. So we haven't seen any problems in this area with permeable pavement. It is a pretty tried and true methodology in this region. We've got several projects within Champaign-Urbana. We've got Farnsworth has done several in kind of the Chicagoland area, and we haven't seen any problems with kind of the big temperature swings and that type of pavement. I think a lot of it is having, you know, a good firm base, and with the permeable pavement kind of profile, you've got a really large storage base, and then a good sized depth of just the kind of permeable layers of pavement.
Great. Another question related to wetlands. Are there any suitable locations on campus where we could consider wetlands that include mussels to aid in filtration? And there's a couple follow-up questions to that as well.
Okay. Yeah, I think so. I think wherever we can put in a healthy wetland, we could have mussel species. I'm not an expert, but it's their natural habitat. So I think that would be wonderful. As Grace had mentioned, in Area 4, we have a really large wetland proposed to handle a lot of the rainwater from upstream areas. That's kind of down south near within the South Farm area. Then we've also proposed a smaller wetland in the Eikenberry Commons area. So it would be a smaller kind of, you know, not a very large one, but it could still have ecological benefits for there. And then along the Boneyard Creek, we have a few wetlands proposed as kind of fringe wetlands, and yeah, different mussel species would definitely be appreciated in the Boneyard to clean the water.
Yeah, and these are kind of seems like ideas along that line as well, but would possible partnerships with academic areas for research or in the vet med area to help in water quality runoff from animal waste be a possibility?
Yeah. I mean, that's really one of my hopes of this program will kind of jumpstart some really neat research with everything going on campus. You know, this is a great opportunity for you know, my background is engineering, so my first thought is, okay, how can you before one of these projects goes in, have students look at water quality, water quantity going off of a parking lot, and then put in a new parking lot and see what the water quality and quantity is afterwards. Same thing with any type of, you know, these wetlands that we're talking about, having students get involved, having professors get involved and come up with different research projects related to them. I think that would be amazing if that would happen. So yeah, start some conversations and kind of keep the conversations going about it, and hopefully some partnerships will come out of this to really facilitate multiple research projects that can be done right here on campus.
Yeah, that would be great. It looks like we've answered all of the questions posted in the Q&A.
Great. Well, we have reached our hour kind of timeline, so we'll go ahead. Morgan, if you want to say a couple things to end, otherwise.
I just wanted to thank you again for sharing this and all the work that went into it. It's got a lot of information that I look forward to digging into in more detail in the coming years. There is a for the folks who are in the audience, there is a few more steps for our final approval of the report, and then we will be sharing that as well. And the slides and this video will end up on the Facilities and Services website, and we will be sure to share it with everyone who had registered for the webinar today. So thank you everybody, and stay green and stay dry. Bye-bye.
Thank you.
Thank you, everyone.